Now class, we're about to go to section 3.4, adding and subtracting mixed numbers. In order to add or subtract mixed numbers, we want to use the following steps. Now, to add or subtract mixed numbers, add or subtract the fraction parts and then add or subtract the whole number parts. Note, sometimes in subtracting mixed numbers, we may have to borrow. Now we have a few examples here, and then we will go to some examples of our own. Okay, now look here at number 1. We have, first of all, these fractions have the same denominators. So we add 2 and 2 sevenths plus 6 and 3 sevenths. So we add the fractions. 2 sevenths and 3 sevenths is 5 sevenths. And then we add the integers, which is, we commonly call these whole numbers, but we should call these integers that are in front of the fractions, but that will be in a later class. So we add 2 plus 6 is 8. So we will have the final answer of 8 and 5 sevenths. Now we go to number 2. Now with number 2, if you notice, these fractions had different denominators. So what we will have to do is what we basically did in the other section. So we will find the prime factorization. Now we know the prime factorization of 8 is 3 2's, and 3 is already prime. They have nothing in common, so we will multiply these. We will have these 3 2's and a 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. So our common denominator is 24, which we have here. So now we would take the new denominator divided by the old or original denominator. So you add 24 divided by 3, and that gave you 8. So remember, it was really like multiplying by 8 over 8, which you see here. Now we go to the second number. We add 24 divided by 8, which is 3. New denominator divided by original denominator. So we will multiply that numerator and denominator by 3. Now if you notice here, the whole numbers or integers stayed the same. You add 2 and 5. Now we multiply these fractions. You got 3 times 8, which gave you the denominator of 24, which we discovered here. And then 1 times 8 is 8. Then here we add 8 times 3 is 24, and 3 times 3 is 9. Now we add them together like we did in problem number 1. We have 8 over 24 plus 9 over 24, which is 17 over 24. And we have 2 plus 5 is 7. Now the one thing I disagree with this example is when you carry these numbers over, you still should put your plus sign here. You still should put whatever operation you're using here. You should not leave that operation out. But aside from that, this problem was done quite well. Now, we need to scroll down here. Now, we're going to get to a subtraction problem. Now, let's take a look here. It says in subtraction of mixed numbers, we have an extra step we must perform if we need to borrow as illustrated below. We have 7 and 3 14ths minus 3 and 6 sevenths. Now, what we have here is we need to find the prime factorization of 14 and 7. We have 2 and 7, and we also have 7. They do not have 2 in common, so we write the 2 down. And they both have a 7 in common, so we only bring down 1 7. So our denominator, our LCD, or our least common denominator, is 14. So now, what we have to do here, which was not shown here, is this here. We take the new denominator divided by the old denominator. I'm going to go with the first one. So we have 14 divided by 14, which is 1. So we were supposed to multiply this fraction here by 1 over 1. Now I had to write it like this because the equal sign was too close. So we will bring our 7 over. 3 times 1 is 3. 14 times 1 is 14. Now we go down here to the second fraction. Now we take the new fraction divided by the original. So we will have 14 divided by 7, which gives us 2. So we need to multiply this numerator and denominator by 2. 6 times 2 is 12. 7 times 2 is 14. Now, what we have here, we have a situation. Our situation is this here. We have a fraction. We're doing subtraction. We have a fraction down here at the bottom that's higher than the fraction we have here at the top. So we cannot take 12/14 from 3/14. So that means we have to borrow. Now, what I want to do is, so we can expand on this a little bit, I'm going to, like we did in section 3.3, I am going to call up basically another, well, it won't be a blank sheet, but another sheet here so I can show you what's actually going on in this problem. Okay, now we have our, wait a minute, let me scroll back here. Okay, we have our 7 3/14 minus our 3 12/14. Now we have to borrow one from this 7. Now this is how we would go about borrowing. Of course, we'll draw a line through the 7 and make that 6. Now our mixed number on the bottom will stay the same, so it'll still be minus 3 12/14. Now here's the thing, since we borrowed 1 from this 6, where does the 1 go? How will we write the 1? Remember, the 1 that we're borrowing is supposed to be added to this 3/14. So this is what we need to do. First of all, 6 will still be our integer. Our denominator will still be 14. We're just trying to find the numerator. Now an easy way of finding the numerator, or let me just say this, let me do it the mathematical way first. Okay, now what I'm going to do below this problem, I'm going to show you every last step that's actually taken. Remember, we borrowed 1 from that 7. So I'm going to just write this here, 7 3/14. We borrowed 1 from that 7, so that's a 6. So this is really 6 14 over 14 plus 3 over 14. Now, the reason why this is 14 over 14 is we look at the denominator of the fraction you already have. Whatever that denominator is, the one that you borrow will have that same number as the numerator and denominator. So we borrow 1 from the 7, so that 6 will become, that 1 that we have with the 6 will become 14 over 14. Now, 6 and 14 over 14 is really just 7, because 14 over 14 is 1 plus 6 is 7. So we really didn't change the problem. So we would have our 6, and we would just add the fractions. 14 over 14 plus 3 over 14 is 17 over 14. Now we go back up here. Now this will give us 6 and 17 over 14, which we did below. Now we combine the like terms. We add 17 over 14 minus 12 over 14, which will give you 5 over 14. And 6 minus 3 is 3. So your answer here is 3 5/14. Okay, now, and I am going to show you an easier way of doing it in just a second. So what we have here is this here. What they did, if you notice here, they put the 1 with the 3/14, and then they made that into an improper fraction. That is another way of doing it, but it still gave us basically the same answer, 3 5/14. Now we scroll down. Now we have another method that says there is a way to solve a subtraction of mixed numbers without borrowing, shown below. Okay, I'm going to show you this method. Now let's look here. The first thing we do here is like we do with division and multiplication of mixed numbers. We change these mixed numbers to improper fractions. Now this is showing step by step. Your denominator stays 14, but your numerator goes like this. You take the integer times your denominator plus your numerator. So that's 7 times 14 plus 3. Then we do the order of operations. Multiplication comes before addition. 7 times 14 is 98, plus 3 is 101. Now we do the same thing down here, but we have 7 as our denominator. So our denominator stays 7. So our numerator, we'll take 3 times 7 plus 6. So this gave us 27 over 7. Now, I don't want to reinvent the wheel here, but remember this. Let's go back up here because we're using the same problem. Remember how we found that common denominator. We did the prime factorization of 14 and 7. We got our 2 times 7 and our 7. We brought down our 2. Our 7's matched up and we counted it once. And 2 times 7 is 14. So we know our common denominator is 14. So now we scroll back to our problem here. Okay, now our common denominator is 14, which is the step 2. Now, again, we do the same thing we did before. We would say the new denominator, which is 14, divided by the old denominator. 14 divided by 14 is 1. So we would take this 101 over 14 and multiply the numerator and denominator by 1, which we see is what we have here. Well, let me scroll up a little bit. Which we have here. Now, we have this here. We take the new denominator divided by the old denominator. 14 divided by 7 gave us 2. So we really multiplied this fraction by 2 over 2, which we have stated here. So now, as a matter of fact, I will put the 1 over 1 here, just so that. So now, we have 101 over 14 minus 27 times 2 is 54 over 14. Now we subtract. Our denominator still stays 14, and we take 101 minus 54, which gave us 47. Now, since we started off with a mixed number, even if the directions didn't ask for it, but they did ask for it here. Now, even if the directions didn't ask us for a mixed number, if you start off with a mixed number and you could get a mixed number for your final answer, you're supposed to get the mixed number. So we would just take 14 into 47. 14 goes into 47 3 times. 3 times 14 is 42. And you have a remainder of 5. Now, when you write your final answer, this 3, all of the digits in front of the remainder, will be your integer. It's only one digit, which is 3. Your denominator still stays 14, and your remainder is your numerator. And that is how they got 3 and 5 14ths. Okay, now we scroll on down here to set A. Now the first thing we do here is find our common denominators. So we find a prime factorization of 9 and 3. 9 prime factorization is 3 times 3, and we know 3 is already prime. These 3's match up, so you count it once. And you have an extra 3 left here, so your denominator would be 9. So we bring down our 4, and our denominator would be 9 here. Bring down our 1, our denominator would be 9 here. Okay, now, this is what happens. I should not have written the 2, but it will end up being 2 9s because the denominator didn't change. But let's just go through the process. The new denominator divided by the old denominator gave us 1. So we'll take this 2 9s and multiply by 1 over 1. 2 times 1 is 2. 9 times 1 is 9. Now we take this new denominator. 9 divided by 3, which gave us 3. New denominator divided by the old denominator. So this 3 will multiply this fraction by 3 over 3. 3 times 3 is 9. 2 times 3 is 6. Now we add the mixed numbers. 4 plus 1 is 5. 2 plus 6 is 8. And your denominator is 9. So this is your final answer. 5